My name is Nathan McLeod. I'm here to present a water conservation project that was funded from the Lohr Foundation's Fieldwork Initiative. My wife Morgan, a soil scientist, and myself, a landscape architect, designed this project together. We recently purchased property on the outskirts of the city of Missoula with the hopes to have a very small farm. We currently have half an acre under cultivation, and we hope to have a flower, fruit, vegetable, and egg farm with a small farm stand on our street and potentially selling at local farmers markets. The challenge that we wanted to solve was that Missoula is an old lake bed. The soil on our property is a sandy loam with a whole lot of cobble, which means that it's really fast draining. In order to grow crops and conserve water on our property, we needed to figure out a way to capture and retain water within the root zone of the soil. Our project utilizes a low-tech method of using topography to capture the water and increasing the water holding capacity of the soil by adding organic matter. Our project approach was to dig shallow basins, approximately 8 to 12 inches deep, in order to direct and capture the water. We would increase the organic matter within these basins using sheet mulch to retain the moisture within the root zone of the soil. Our experiment uses moisture sensor probes installed within the basins and in control areas to compare soil moisture. So what does the data say? The soil moisture sensors record volumetric water content. We had 3 within basins and 3 within control plots that included amended soil, but not in a basin. What we found, it works, but maybe a little bit too well. Basically, all 3 basin plots show that the soil stays wetter for longer than the control areas. So what did we learn? One thing was that we planted crops both in the basins and also in our control areas. We ended up irrigating to the moisture needs of the crops in the much faster draining control plots, which resulted in the basins being overly wet and the crops failing. The irrigation was designed to be uniform for easier comparison, but we learned that we need to separate the basins from the control areas. The other issue was that the sheet mulch really needs a year to compost before planting. Because of the timeline of the project, we planted directly into the sheet mulch, which also led to the basins being too wet and the crops failing. Moving forward, we plan to adjust the irrigation system to have the ability to separate the basins from the control areas, and will ensure that the sheet mulch is fully composted and incorporated into the soil before planting. Despite our failures, we do feel that this project was a success. We did learn that our theory works. We're holding more moisture for longer within the basins, which we think will result in the need for less irrigation over time. We want to thank the Lohr Foundation for funding this project. We think it's really neat, and we think it's a fun project to be able to share with folks. Thank you.